Bismillahirrahmanirrahim. In this session, we will discuss exercise 36.11. This 36.11 is basically based on sine rule and cosine rule from the topic trigonometric topics for mathematics course for IGCSE and O level. In the previous session we have covered up to question number 6. Now we are discussing question number 7 onward. Let's start to question number 7. We have this triangle. This is a non-right angle triangle. So here let's start with this. We have this 3 sides. We have given one side 11 centimeter and 2 angles 40 and 95, and we have to find the remaining unknown, that this angle capital Z and this is small x, and in the front of in opposite of this y, capital Y angle, we have small y, and we have to find small y, and against this z angle we have this small z. So this is 95, this is 40, so this angle can be obtained as 180 minus 40 plus 90. So that's where we can obtain this. Similarly, by the using sine and cosine law, we can obtain the other values. So we start this one. Question number 7, y, z and small z, and we have to find the angle z, capital Z is 180 minus 95 plus 40, and here we have 45 degree. Using sine rule, sine x upon small x, this is sine x and this is x, and this is sine y and this is small y. So we can place values x, small x and y, and small y can be obtained, and this is 7.1 centimeter using sine rule. Similarly, using z and this z, so small sine x upon small x is equal to sine z upon small z, and small z is z sine z sine x and x. This is sine 45 degree, sine 95 degree, 11, and here we have 7.8 centimeter. So this is question number 7. Solve question number 11. 2 points A and B are 30 meters apart on a horizontal ground. This is a horizontal ground, and this A point and B points, there is a difference, or there is a distance between A and B is 30 meters as given. The angle of elevation of the top, this capital T of a vertical tower, this height of this tower is a capital T, and C from A and B are angle 27 degree, and from B the angle is 40 degree respectively. Find AT, this length, and BT, which is this length. Find the height of the tower TC. So let's solve question number 11. Two point A and B 30 centimeter apart in a triangle A, B and T. So this A, B and T, this angle is basically 140 degree, because this is 40 degree, so 180 minus 40 is 140 degree. So we have ABT, this angle is 140 degree. So ATB, similarly ATB is 180 to 27 plus 140, so the angle is 13 degree. Using sine rule, this angle and this side, and this angle and this side, so ET can be obtained. So sine 13 degree upon 30 and 140 degree upon capital AT, and AT can be obtained. Sine 140, sine 13, 30 degree, and the result is 85.7 meter. Again, for this triangle, sine 27 degree, sine 13 degree, BT and 30, this side. So on this triangle we have this. So this is 27 degree and opposite of this is this BT. So sine 27 degree upon BT. This is sine 27 upon BT, and this is sine 13 degree upon 30 meter, which is here. So by using this we can obtain value of BT, and sine 27 divided by 13 degree and into 30 is equals to BT. So the BT value is 60.5 meter. AT is 85.7 meter and BT is 6.5 meter. Now we have to find this height in a part B. So in triangle ACT, this triangle A, C and T, sine 27 degree is equal to TC upon AT, and we have TC is equal to 85.7 into sine 27 degree, which is 38.9. So the TC height of this building is 38.9 meter, which is very easy. So we have used this triangle, right angle triangle, and we have used sine. So sine is perpendicular upon hypotenuse. So this is AT is hypotenuse, which is obtained earlier in part A, and this angle is given and this height can be obtained. This is very easy, and the height of the building is obtained as 38.9 meter. So let's solve question number 12. A river has two parallel banks. This bank, one of the bank is this, and the other one is this side. Point A and C are on one side of the river. This A and C are on the one side of the river, and point B is on the other side. The angle from these points to a tree B, here we have a tree B at point B on the opposite banks are 68 degree. The angle from these points to a tree B on the opposite banks are 68 degree and 34 degree, which is given here. This is 68 degree, this is 34 degree, and is shown in the diagram. Find AB, this AB and this BC, and find the width from this line to this line, so perpendicular distance of the river. So let's solve this question number 12. This AC and BC. So angle B is 180 degree minus 68 plus 34, 78 degree. So obtained. And sine 34 degree upon this AB, and sine B, which is 78 degree upon 45 degree. So with this information AB can be obtained, and AB is obtained as sine 34 degree upon 78 sine 78 degree into 45 degree is equal to 25.7 meters. So the length of this AB is 25. Again, with using this side angle, we can 68 upon BC and sine 78 degree and 45 degree, and BC can be obtained. Similarly, this is 42.7 meter. And in triangle ABD, here we have this point D, which is the perpendicular distance. So ABD, this we have to find the AD. Sine 68 degree, BD and AB is BD upon AB. So this BD, which is the perpendicular distance from here to here, is obtained as 25 into 6 sine 68 degree, and the width of the river, that BD, is 23.8 meters. This is very important. Similarly, the other question that's important. Here we have a cuboid in question number 14. A, B, C, D, E, F, G, H. A, B, C, D, then E, F, G, H. A, H, C. A, H and C is 80 degree. A, H and C, this angle is 80 degree. Calculate the size of these triangles. ACH. ACH. This angle C. So AC is basically AB in plus square plus BC square. This is Pythagoras theorem. Simple Pythagoras theorem. So AC square is equal to AB square plus BC square. So AC is obtained as 9.2 centimeter. So this is 9.2 centimeter, and HC is equal to this length and this. This is 6 centimeter and this is 3 centimeter. So 6 centimeter square and 3 centimeter square, which is 45 under root of it, 6.7 centimeter. And then tangent BC upon AB, CAB. C, A and B. C, A and B. This angle. CAB is equal to BC upon AB. This BC is the right angle triangle upon AB. This is perpendicular and this is base. So CAB, tangent TCAB is obtained as BC upon AB, which is 7 upon 6, and CAB can be obtained as angle 49.4 degree. And similarly, tangent DAH and can be obtained as this 23.2, and similarly DCH can be obtained. So we should see this kind of triangles are basically right angle triangle, and so these angles can be obtained through this sides length and then tangents. So we actually take the angles and the remaining heights on the perpendicular side and the base side, and then take the angles to evaluate the degrees angle, so which is used here, and obtained angles. This is not very important question, because this kind of questions are never asked in final exam, but it helps to improve learning. In the next session we will discuss